Hello, welcome back. This is the third and final part of our bottom-up functional immutable Mars Rover kata in TypeScript. It's been about 2 months since I recorded parts 1 and 2, so I might be a little bit rusty, forgive me. But somebody said, when are you going to record part 3? And I thought I should probably actually do that. I've just been a bit busy. So if I recall correctly, in part 2 we had managed to write a execute function, that's this function here, that takes a string of commands. So that is a string like this one here, lum, 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 and it applies that to an initial rover state. So we give it a rover at 1, 2 north and a big long string. It applies each one of those commands in turn and then gives you back the new state. What I want to do today is to be able to handle this complete input and return this complete output. Before I can do that though, there is currently a bug in the code, which I'm going to show you. So if I copy paste this, and instead of using this lum 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 string, what we're going to do is we're going to use this mum 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 string. So our rover starts facing east at 3, 3, and we expect it to be facing east at 5, 1, I think. We'll double check that in a second. And then we go paste that in there. We're going to need one of those, and we save that. That should fail. And the reason it fails is that in our execute function, we aren't using this apply function correctly. So what we're doing here is for each command in our list of commands, we are applying that command to the initial state. What that means is we are only ever getting the result of the final command. So when we are facing 1, 2 north, we apply all of these and we discard them, and then we apply this move to 1, 2 north, which takes us to 1, 3 north. This one, we're applying this move to 3, 3 east, which gets us to 4, 3 east, which is why it's failing. So what we need to do is we need to come back in here, and instead of applying to state, we should apply to result. And that should now be green. There's actually a way to rewrite this so that we can't have this problem. So there's a refactoring I didn't do, which is we want to be able to turn execute into a reduce. And a reduce takes a list of things and it applies a function to them one after another, and it accumulates the result. So for that to work, what I need to do really quickly is I'm going to change the order of these args. So command is a string, which should still be green. We're not green because I need to change them here as well. We say result and command. That should be green, which it is. And what I can do is I can rewrite this to say execute is what you get if you do commands.split on the empty string and you reduce that with apply on our initial state. And that's green. So what this is saying is for every command in command split, apply that command to our state and then apply the next command to the result of that, and so on and so forth. And that's all cool and groovy. So with that, so we've fixed our bug. Let's have a look at what we want to do next. So we've got our tests working on execute. And what I want to do is I want to start by processing this complete input. But there's obviously a long way to go from being able to parse one string to being able to parse this whole block. What I'm going to do is I'm going to write a single test, and then I'm going to slowly refactor my test and my code in lockstep to get me to parsing this complete block. And the reason I'm going to do that is this is too much for me to take on in one step. But the intermediate steps aren't interesting to me, okay? I don't want a function that can take just this one line and do something. I don't want a function that can take just these 2 lines and do something. I want a function that takes all of this. That function is too big for me to write. So what I'm going to do is I'm going to work in little steps. I'm going to change my test and my code in parallel. You'll see what I mean. So we're going to write a new function, a new test, test. When executing a program, which is what I'm going to call this thing we're doing, we're going to take program, which is a list of strings, and we're going to execute something. Okay, our first program is just going to be the program. We're going to say 1, 2, n. Okay, so we're just going to take this string here, because I know how to handle this. This is going to give me back a rover that's facing the right direction. So we can say const program equals 1, 2, n. Expect when I run my program, that's going to equal rover facing north at position 1, 2, like that. Okay, that's going to fail because run is not defined, so we need to quickly go and define run. Const run is a program, is a function. It takes a string, which right now is location, and all it does is it says const x, y, heading equals string.split equals location.split on the empty string, like so, and then we return rover with our heading, and then parseInt x and parseInt y. Okay, and that gets us to green. So all we've done is we've taken this input 1 to n, we split it out, breaking it up on the white space character, and then we return a rover, and that's all cool and groovy. So the next thing I want to do then is I want to be able to execute some commands on my rover. So I'm going to say, actually, a program is an array of strings. I'm going to do multiple strings at a time. The reason for that is that eventually I'd like to be able to plug this into an actual command line tool, and that command line tool is going to take in input from standard in, or from a file. It's going to read it line by line. So I'm going to treat our input as a list of lines rather than just one big string. So our program is now a string array. Let's make the same change here. So our program is going to be a string array. We're going to say, let's rename this to program. We're going to say const location program, like that. So we're going to take the first string out of our program. I'm going to work with that one. And I think that should still be green. That's still green. But now what I can do is I can pass you the string lim, like that. Lim. And now I can expect that my program, that running my program is going to equal 1, 3, n. That's going to fail because we're not executing our commands. What I can now say is const location commands equals program. We get our initial rover state, and then we are going to execute some commands on it. So the first thing I'm going to do is I'm going to come back to where I was green, because I want to pull these two lines out into their own function. So I'm going to say const initial state equals location of string, and it just does this. So I can say return, we're going to say location and commands equals our program. We're going to return execute with commands, then initial state for location, like that. Now I can pass you our lim string here, stick you in there, run that. Now then, why did that not work? Oh, because I've not updated my test. That is 1, 3, n. Green. Okay, cool. So what have we done? We have written a test that takes one of these strings, 1 to n. We got it green. We modified our test and our code so that it now takes two strings and it does something else. and we're still green. So what we're doing is we're working piecemeal, right? We're going to slowly make our test and our code more complex in tandem. And that's because going from nothing to all of the strings at once is far too big a step for me to take on. I'll screw it up and that'll be embarrassing for me because I'm on camera. But the intermediate steps aren't very useful to me. So I'm going to throw them away each time. I'm just going to rewrite them. I'm not going to try and have a load of functions that do these little pieces one by one. So when executing a program, I can now take one of these locations and one of these command strings. The next thing I want to be able to do then is to be able to handle multiple rovers, right? So in the input, we're given these two rovers and we expect these two outputs. The problem I've immediately got is that my execute function right now returns me a single rover. There's a couple of things I could do about that. Either I could return an array of rovers. That seems like an obvious next step. Actually, the way the problem is described, really I want run not to return me a rover, but to return me an array of strings. Okay, so run is going to take an array of strings, that's our input. It's going to return an array of strings, that's our output. So let's fix our existing test so that instead of returning a rover, I'm going to return the string 13n. That's obviously going to fail because we're returning a rover, not a string. I'm going to write myself a new function quickly. Well, I'm not, I'm just going to do it in here. No, I am going to do this. I'm going to say return print execute, where print is a function that takes some state, which is a rover, and it returns dollar state.position 0, and we return dollar state.position 1, and we return dollar state.heading. We save, and we're green. So now instead of returning a rover, I'm just returning that rover's current state as a string, and that's green. With that then, I can say that my run should in fact return me an array of string. Let's do it that way there as well, so we're consistent. So it can be array of string. That's not happy because at least the types aren't happy. So we can quickly hack that into place. We can return an array of string. And I'm expecting this now to receive this array here. Grooving. So the next thing I want to do then is I want to be able to handle multiple rovers. So I'm going to come back in here. I'm going to go 33e and 33e. And we're going to expect this now to give me two strings. It's going to be 13n and it's going to give me 51e, like so. Clearly that's going to fail because we're only executing a single rover. So what did that return? That just returned me 13n, which is great. So what I need to do is instead of just handling two strings, I want to iterate through this list of strings and I want to consume things off it. So what I'm going to say is while program.length is greater than 0, I'm going to say const location in commands equals this way, and then I'll split it up later. Program.shift, so that pulls the first element out of an array. Program.shift. I'm going to say output is a new array. I'm going to say const state equals execute commands on location. And then I'm going to say output dot push print state. And then down here, I'm just going to return output. That should work, I think. Seems about right. Output any type. That should be a string array, but you are not happy. Why are you not happy? Location here shouldn't be a string, right? This should be initial state or location. And then why are you not happy? You are not happy because I've misspelled output. And now we're green. Okay, so barring a couple of typos and one brief brain freeze, what we've done is we've taken our program and now we can handle like a list of rovers, like an arbitrary number of rovers. So I'm feeling pretty good about that. That is pretty much working. So now we're handling the 2 rows we're giving in the problem. There's only one more string to do in the problem statement, which is the size of the grid. Actually, the way the acceptance criteria are defined, that doesn't matter at all. I can just do program.shift up here, pull that off, and we're still green, right? We can just ignore the size of the grid because the way the problem is set up, these rovers only ever move around inside that grid, right? They never try and get off the edge. But that's kind of disappointing to me, right? Because if we have the size of the grid, it feels like we should be able to handle the case where actually we move off the edge. So let's have a look at what would be involved if we wanted to do that, right? Let's write ourselves a new test. Test. When moving off the edge of the grid. We're going to say our program, we have a 0, 0 grid, okay? So there is only space for the rover where it currently is. It can't move in any direction or it will fall off. We're going to say we have a rover, it's at 0, 0, has to be, it's facing west, and we move it. If we run that program, then I expect that to give me back F for failure, and then I want to see where the rover was when it stopped. That's going to fail because it's going to give me like -1 or something. Yes, that moves off the edge of the grid, right? Just ignores me. Also, this returns me an array, so let's do that. So at least my types are correct. Yeah, so that fails because instead of failing, it just returns me -1. So let's have a look at our code and figure out what we would need to do in order for this test to work. So here in our index, we've got this execute. Execute is just applying commands to our state. So apply really should fail to apply a command to our state, which is going to take us off the edge. We can always turn though, right? If we are at 0, 0 and the grid is only 0 by 0, we can always turn left or right. That's always a safe operation. Really what we need to change is move. Move is going to need to say if our next position, so when we get the next position, if that takes us off the grid, then instead of updating our state, we should fail. So the question is, how do we fail? All right, we could write some kind of exception, but that's going to mean try catches all over the place, it's going to make a big mess. Instead, what I want to do is I want to introduce the concept of a success or failure result. Okay, so we're going to have a type. It's going to look like this. It's going to be type execute result. And an execute result is a rover. And it is a brand, so it is a rover that is successful, or it is a rover that is failure. Let's move this down here, that, I'm going to export it. Okay, so this is an intersection type. So execute result is either this type here or it's this type here. And this is just extending our rover and it's adding on this extra field, this underscore field, that is the literal string success or failure. What I can do with that I'm going to come back to my tests, and I'm going to ignore this test for a second because it's red. What I want to do is I'm going to keep my tests green, and I'm going to make execute return me one of these things. So we're going to come into here. You say that execute is going to return from apply. Apply no longer returns a rover. Instead, it's going to return me an execute result. Which means it needs to take an execute result. Which means that turn left and turn right both need to take an execute result, which is easy because we can just say that rover, this returns me an execute result. So we said that for rotate, that's easy. We can always just return success. Okay? So rotate now returns me an execute result. I can do the same thing for move, right? I can say that move doesn't return me a rover, it returns me an execute result. And right now I'm just going to hard code success. Okay, so move is always successful. So now apply takes an execute result and returns an execute result. And execute returns whatever apply returns. So all I need to do here is I need to say, when we first start off this apply, we start off with a successful rover. Okay, this fails, and the reason it fails is that all of our tests are expecting us not to return the success or failure thing, but just a rover. Let's come back and look at our tests. Really, there's two things I can do here. The first thing I can do is I can fix this properly. Okay, so I can say something like, in jest, I can say, so right now we've got 13 failed tests. In jest, I can say this is going to equal expect.object containing our rover. Okay, so I can just ignore any extra fields. And that should work. So instead of having 13 failed tests, I'm going to have 5 failed tests. But actually, what I'm going to do is more radical than that. You'll note that I've currently got 100% code coverage. But if I come into here and I delete all of my tests except our acceptance test that exercises through run, we should find that we still have 100% code coverage. And the reason for that is this test using run exercises every part of our code. Okay, so in order for this to work, turn left has to work, turn right has to work, move has to work, execute has to work. The whole thing is invoked, right? So what we've done is we started off writing tests against turn left and turn right. Then we took a step up and we treated execute as our interface. And we tested against that and got rid of our initial set of tests. Now what we can do is actually we can rewrite our tests again in terms of run. We can throw away all of our tests against execute. And we can just treat execute directly as run directly as the interface into our program. I've done that, let's not do that. Back, yeah, it's fine. So what I want to do, the reason I'm doing that is I'm lazy. So practically, I would almost certainly still have some tests against turn left and turn right. I would maybe not bother with execute. I'll probably rewrite those in terms of run. But for the purpose of this exercise, because I just want to make it easy for myself, I can just throw away all of the tests that are breaking because I still have 100% code coverage. And what you'll note, I guess, is that if we'd started writing tests outside in, we probably would have ended up with something that looked like this. Actually, we've been able to start instead with this kind of inside-out approach where we've tested very small pieces that were very safe and easy to work with, and slowly we've refactored ourselves outward so that we don't have any coupling to any of the implementation detail anymore, which I think is kind of cool. Okay, so I've got this one failed test, which says that I'm expecting this to be -1, 0, W, but actually, so I'm expecting it to be foo, but it is -1, 0, W. That should be fairly easy for us to fix, right? So what we can say is move. Right now, move always applies the next position and returns success. I want to change this completely. So we're going to say next pos equals get next position for rover dot is it heading in position? Yep, heading rover dot position. Then I can say if next pos 0 is smaller than 0, or if next pos 1 is smaller than 0, then we're going to return state, but branded a failure. Otherwise, we're going to do what we always did. We're just going to return state position, next position. Like that. That should be green. That is not green. State is not defined. That's because it's not called state, it's called rover. So move doesn't actually take a rover, right? That's a lie. It actually takes state, which is an execute result. You are state, and you are state. Okay, so that nearly works, right? So now we're at the right position. We're at 0, 0, W, not -1, 0, W, but we don't have this F on the beginning of our string to tell us it was a failure. So what I'm going to do is I'm going to come back to our print function. We're going to say this. We're going to say location equals that. And then we're going to return state is an execute result. State success. Then we just return location. Otherwise, we return the string F with location. And now we're green. So far, so good. What I want to do before I go any further is I'm going to take these functions we've written as part of this whole malarkey, and I'm going to stick those into our index so we can export run. Come back in here. We're going to import this from our index. Pragmatically, in a real program, I'd probably separate run from the domain model. So I might have like a domain module, and then separately I'd have like a runner module, which has got that kind of run and print. Because what that lets me do is it lets me separate the abstract domain model from the machinery that I need in order to make the input-output work. So what do we got here? We have got this rover function, which I'm not currently using, so I'm going to get rid of you, which means I can get rid of you. Right, yep. And then you are unhappy because rover is not defined back through here. So what I've done is this initial state function uses this function rover that we created as a helper method. I think what I'm going to do is I'm just going to inline it. So I'm just going to say we're going to return heading, and then position is the array where we have parsing x and parsing y. and we're green. So what we've done is we've moved the production code out of our test module. So you can see that right now we've got the entire code base tested with just these two tests. And again, in practice, I would likely have more than just these two tests. This way, I can feel free now to go in and change any of the implementation details of execute or turn left or turn right or whatever I like. My tests won't need to change because they don't even know that those functions exist. Right? I can completely rewrite everything that happens inside run, and my tests will continue to pass. So let's quickly do the second case. We're moving, so we're moving west off the edge of the grid, and we're moving south off the edge of the grid. So we're going to be facing south. We're going to move. This should fetch this result. I'm going to save. You can see that maybe we can use test each here to clean this up, but we'll not go there right now. That one already passes because in our move function, we already wrote this conditional to say if y is less than 0, then that's a failure. Shouldn't have done that really, but it's fine. So let's try a case that we expect to fail. So when moving north off the edge of the grid, so we're going to pass this facing north. We move, we would like it to be facing north with a failure. Actually, what will happen is we'll just move quite happily to 0, 1, n. That's what we get 0, 1, n. So to make that fail, what do we need? We need for our move function to understand the size of the grid. That means in turn our apply function needs to understand the size of the grid, and finally our execute function needs to understand the size of the grid. So in run right now, all we're doing is we're taking that size and we're just dropping it on the floor. I'm going to come back to my tests, and again I'm going to ignore this test. I want my tests to be green. We're going to try and refactor so that we thread that size through. So let's see what we've got. In move, we need the current state, and we want the size of the grid. I'm going to say that the size is going to come next. So actually the size of the grid is defined by the maximum XY coordinate, right? So like the top right corner of the grid. So I'm going to say max position, which is a coordinate. Coordinates, like so. And we are just going to ignore it. That's green. We are going to pass that into here. So firstly, we need to receive it. So we are going to receive max pos, which is a pair of coordinates. And we're going to pass that in here, max pos, like so. And we are still green. And then when we execute, we will need to pass that into our apply. Now then, that's not going to work because we've changed this to this reduce. So actually I'm going to undo that change. Is that what I want to do? So our reduce function requires that apply has only got two arguments, right? It requires that it's got the current state and the next command. I could put the maximum size onto our execute result, but I don't really want to do that. So I'm going to come back and I'm going to undo this rewrite that we did. So we're going to say, const result equals state. And then we're going to say for const c of commands.split on the empty string, we can say result equals apply result c. That way around, yeah, result c. You're complaining because you want an extra arg, so we're just going to say max pos, which we'll come to in a second, and then we're going to return result. And you need to take max pos, which is a coordinate. You need to be let, not const. So let result for const c of commands apply result c max pos. And state needs to be an execute result. not Rover. That is us happy. Okay. So then the last thing I need to do is to say when I call execute in run, I'm just going to pass it right now, 5.5. No problem. Initial state should return us one of those. Let's update that. So I want to say the initial state is going to return me success. Okay. So we're green. So what have we done? Initial state is now defined to return us an execute result. Make that explicit. Return us an execute result. Our run passes the initial size into execute, which in turn passes it through to move, which in turn, then we can check it. So what I need to do is I need to say here, where we're right now just taking that initial size and dropping it on the floor, I need to actually parse it. So I'm going to say const then instead of passing 5.5, I can pass max pos. Okay, so far so green. We're not using that max pos anywhere because we added the type sig. We're not using that yet, but we come back to our test. Now I can come in here and using the max pos that I passed through, I can come back to move and I can add into here. I'm just going to do this. I'm just going to stick it straight in here. I know it's going to be ugly. I'm going to say if next pos 0 is greater than max pos 0, or next pos 1 is greater than max pos 1, then this is a failure. That should be green. It is. This is quite ugly, so I'm just going to refactor that out. I'm going to say const out of bounds. It's a function. It takes next, which is coordinates, and max, which is coordinates, and it just returns us this expression. So this is next. Next. Max. And then we say if out of bounds, max pos. That's a failure. Okay, cool. We are green. So I want to quickly add in the test for east, just to make sure that works. So we start with 0, 0. We are facing east. We move. We should be facing east with a failure. That's green. Which leaves me one final test, which is what happens when we fail halfway through. So we want to say, I've got a grid. It is 0, 0. We're going to face north. We're going to move off the edge of the map. We're then going to turn left. We're going to turn left again. So now we're facing south. And we're going to move. So this should leave us facing north, right? We should be unable to move off the grid in the first place. Actually, I think what will happen is we'll move off the grid. We'll turn left. We'll move south. And we'll still be at 0, 0, but we're in a fail state. So there we go. So we have moved off the grid, we've turned south, and we've moved back again. And obviously, that's not correct. So what I want to say is, once we've failed, that's where we stop our iteration. So we're going to say in here, for const c of command split, result equals apply. And I guess the easiest way for me to do this is to say if result is failure, then break. And that is us green. So with that then, that is now handling moving off the edge of the grid, moving off halfway through the thing. We've now got a solution that takes our initial input, returns our initial output. I'm going to leave that there for today. Quickly running through, again, we started off, we wrote tests against the smallest units of our code. So we wrote a single test against turn left. Then we wrote tests against turn right. We noticed that there was duplication. We refactored to introduce rotate. We wrote move, again, starting off just against that move function. Then we took a step up. We rewrote our existing tests to use the execute function that invoked turn left and turn right on our behalf. Then once we got all of that working, then we took another step up and we wrote just one test, this executing a program test, which we slowly refactored until it did everything that we needed. Once we'd reached that point, we could come back and delete all of the tests we'd already written against execute whilst maintaining 100% code coverage. So this is how, even though we've started off writing tests against these tiny little units of our software, we can end up in a position where our tests are not coupled in any way to our implementation, because we can continually refactor what we're doing so that our tests are always working at the highest level of abstraction that they can. I hope that was at least vaguely useful and or interesting. I am going to try and do some more of these. I think probably the next one I will do is Mars Rover outside in using tell don't ask. But I've got another idea for something I might have a go at. It's kind of been kicking around on Twitter from G. Paul Hill and Ron Jeffries in kind of the same vein. I'm Bob. Thank you very much for watching. Please do let me know what you think and have a good day. Bye-bye.